We're moving right along into section 3.3. We've been talking this unit about polynomials, and today we're going to talk more about dividing polynomials. This is going to lead us into some more ways to actually solve polynomials here. So in chapter 2, we did talk about operations on functions, and we talked about things like this. If we had f of x is 3x plus 5 and g of x is 2x minus 7, then f divided by g of x, what we did in unit 2 was we just said that's 3x plus 5 over 2x minus 7. Today we're going to look at some more ways to actually get that division done, to simplify it, and maybe to use it to find some solutions. It helps to remember, if we're going to do polynomial long division, how to do regular number long division. So if I had this example right here, 2273 divided by 5, long division, if you remember back to 5th grade, 4th grade, whenever you did it, the divisor goes outside. This right here is the divisor, the number you're dividing by. The dividend goes inside, 2273. That's the dividend. And your answer up here is going to be called the quotient. And the way that you did this when you were back in 4th, 5th, 6th grade, long division, there was a set of 4 steps. Divide, multiply, subtract, bring down. And you would basically repeat these steps over and over until you got to the end of the problem and there was nothing left to bring down. So let's look at the example that we have. 5. We say first, can we divide 2 by 5? No, we can't. Can we divide 22 by 5? Yes, we can. And we're going to basically say 22 divided by 5 in the calculator and see what that number is. 22 divided by 5 is 4 point something in the calculator. So we put our 4 at the top. That's the divide step. Next is multiply, and we're always going to multiply by this number here on the left. So let's see, when we do 4 times 5, we get 20. Next is subtract, so we need to subtract this whole thing. 22 minus 20 is 2. And then is bring down. So we need to bring down at least one thing. We could bring down that entire thing if we wanted, but I'm going to bring down one thing here, one item. All right, now we just loop back and repeat the steps again. Can 5 go into 27? Yes. 27 divided by 5 is 5 point something. 5 times 5 is 25. Subtract, you get 2. Bring down, you get 23. 23 divided by 5 is 4 point something. 4 times 5 is 20. Subtract, bring down. There's nothing left to bring down here, and so we know we're done with the problem. And this right here is our remainder. And the way you write your solution is as quotient plus remainder over divisor. And so our answer is 454 plus 3 over 5, or 454 and 3/5. We need to remember this. This is what we need to remember. The long division process and the way that the solution looks like. So the solution is always going to be quotient plus remainder over divisor. All right, you remember this from middle school. Now let's try and apply that to a polynomial. We're dividing 6x to the third minus 5x squared minus 3 divided by 3x plus 2. If we're using long division, I'm going to show you another division type here in a minute. The divisor goes outside, 3x plus 2. The dividend goes inside, and the important thing with polynomial long division is that we fill in all the place values, if you will. So that's 6x to the third. The next thing I need is x squareds. I have negative 5x squareds. The next thing I need is x's. How many x's are there? There are 0 x's in the problem. And then the next thing will be our numbers without the x's. We want this always to be in descending order here. Where our highest exponent goes first, and then we go down by 1, down by 1, down by 1. All right, let's try and do this long division problem here. can I put 3x into 6x minus 3? Remember, we're doing the same 4 steps. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. So divide 6x to the third by 3x, and you'll get 2x squared. A lot of people like to line this up so that 2x squared lines up with the x squareds there. That's perfectly fine. Next is multiply. So I'm going to multiply. When you're doing the divide step, you're only dividing the first term by the first term. That's going to be enough for you. So multiply 2x squared times this entire thing over here. So 2x squared times 3x plus 2. 2x squared times 3x is 6x to the third. 2x squared times 2 is plus 4x. And you know that you've done the step right if these two items here match up. Because the next thing we want to happen is when we subtract, those two items will go away. 6x to the third minus 6x to the third, those go away. We are subtracting that whole line, so I've got negative 5x squared minus 4x squared is going to be negative 9x squared. That's the subtract step. And now we need to bring down. Again, you can bring down as many of these things as you want. With polynomial long division, I sometimes prefer to just go in and bring down the whole thing. All right, we're back to our divide step. Remember, when we get done, we just loop back to the top. So divide 9x squared, actually negative 9x squared, by 3x. We're dividing this by this, first term by first term, and you will get negative 3x. And you know that you'll have done it right because when you multiply negative 3x times this thing out here, you get negative 9x squared minus 6x, and the first terms match up. So that when we subtract, the first terms go away, and 0 minus negative 6x gives me 6x. Bring down the minus 3. One more time. We could divide 6x by 3x, and we'll end up with just a positive 2. I'm multiplying again. 2 times this entire thing on the outside would give me 6x plus 4. Subtract gives me negative 7. And since there's nothing left to bring down, that's my remainder. So that's the quotient, remainder, divisor. When I write my solution, I need it to look like quotient plus remainder over divisor. And so that's 2x squared minus 3x plus 2 plus my remainder, negative 7, over my divisor, 3x plus 2. That probably took up a lot of paper space for you. I understand that. Long division does. There's a time and place for long division, but there is a shorter method called synthetic division that's going to work in a lot of cases for you. Here's another long division problem. I would pause the video here, see if you can work your way through and get the answer. I'm going to erase my work now so you can see. Remember, the answer is quotient plus remainder over divisor. So this is what my final solution looks like here. Some of these problems on ALEKS, sometimes it will just ask you for the quotient, in which case you would type in this. Sometimes it will just ask you for the remainder, and you would just type in this item down here, right? It just depends on how the problem is asked. And there's your divisor to fill that out. So it's quotient plus remainder over divisor. All right, one more, using long division again. Divide using long division. This looks like a fraction, but a fraction is just division, right? If you typed in 5 over 4 in your calculator, that's the same thing as 5 divided by 4. So again, divide, multiply, subtract, bring down, and then we'll look back to the top. So first, divide. 2x squared by x would be 2x. I'm going to line these up here. 2x. 2x times x minus 2. Remember, we're multiplying by this entire thing. Would be 2x squared minus 4x. Subtract. That would be 7x, negative 7x. Bring down. Then we'll loop back. So divide. Negative 7x by x would be negative 7. multiply, that'd be negative 7x minus 14, subtract 0. Nothing to bring down, so we're done. We get a 0 remainder. That's great. That means that we divided it evenly, right? If we get a 0 remainder, that means that it was an even division. And so when I write my answer, quotient plus remainder over divisor, if this thing is 0, I can leave off this entire fraction part here. If that's 0, I don't have to write that in. So my answer is just going to be 2x minus 7. Because 0 over anything just turns to 0. That's why I can mark out that fraction term. You really are hoping that you get a 0 remainder. If you get a 0 remainder, that means that it divided evenly. You don't always get a 0 remainder, as we saw in these last two problems, but that's what you hope for. All right, synthetic division. So synthetic division, like I said, is the easier method. It's the shorter method. It takes up less paper space, but it's sort of limited in the times that you can use it. And I'm going to tell you, you can use it in a lot of times that I'm not going to show you, but the typical time that I would turn to synthetic division as opposed to long division is when your divisor looks like this, where it's just x and a number. So like x plus 6, x minus 5. You can do it if your divisor is something like 3x minus 7, right? You can. It's just easiest when it's just x and a number, right? A simple binomial. Synthetic division, here's what it looks like. It's the opposite size shape as long division, and it takes up 2 lines on your paper, right? I'm going to get rid of these dashed lines and just understand that this is 2 lines tall. Whatever makes this 0 is going to go on the outside. So positive 4 minus 4 is 0. If you messed up on synthetic division, it's because you put a negative 4 out there instead of a positive 4. You're always looking for what would make this 0. Make the divisor 0, right? Because 4 minus 4 would make that 0. Next, the items that go in this top row here are going to be just the coefficients of your dividend. And it does need to be in descending order. So I'm going to rewrite it real quick as 2x to the third minus 10x squared. Again, I'm missing the x term, so 0x minus 5. Any of the terms that you're missing, if we want it descending, 3, 2, 1, none, any of those terms that are missing, you need to fill them in with a 0. Now, only the coefficients go in the box. So 2, negative 10, 0, negative 5. I bring down the 2. That's the first step. Every single time, that's the first step. You bring down that first item. And then instead of divide, multiply, subtract, bring down, we only have a 2-step process. It's multiply, add. And then we loop back. Multiply, add, multiply, add, multiply, add, multiply, add. Anytime you multiply, you're multiplying by this item right here. You're multiplying by that 4. Anytime you add, you're just adding straight down a column like you would have done in 2nd grade, whatever. So first, multiply. Again, I'm multiplying by this number right here. So 2 times 4. That would be 8. Now add. Negative 10 plus 8. Negative 2. Now we loop back. Multiply. Negative 2 times 4 is negative 8. Add. Negative 8. I'm just adding straight down, right? Then multiply. 4 times negative 8 is negative 32. Then add straight down. 5 plus negative 32 is negative 37. This number on the end is your remainder. And what we're going to do is, since we're dividing x squared, I'm sorry, I need to look at my descending order. Since we're dividing x to the third, we're dividing something whose highest exponent is a 3 by something whose highest exponent is a 1, right? Then our new exponent is going to be a 2. Our new highest exponent is going to be a 2. This is why I said it just takes a lot less thinking if this is just x and a number, because what you're going to do is you're always going to start with 1 less than your highest exponent. You're always going to be essentially subtracting a 1 here if that's true. So my highest exponent was x to the third. My degree was 3. My highest exponent was x to the third. That means in my solution, my highest exponent is going to be 1 less than that, so 2x squared, right? This is my coefficient, and I'm going to start with a degree 1 less than your original dividend. All right, so next is the -2. We're just writing it in descending order, so I've got an x squared, then I've got an x, then I've got a number without x's. And then since I want it as quotient plus remainder over divisor, my remainder is -37. My divisor was x minus 4. And that's my answer. Quotient plus remainder over divisor. This is your divisor. This is your remainder, the last item every time. And the quotient is coming from these coefficients here. Here's another one. I've already written it for you in descending order. You should take a second and see if you can work this out. And this is what your solution should look like when you write it as quotient plus remainder over divisor. All right, so there's a theorem called the remainder theorem, okay? And what the remainder theorem says is basically up here, if I was to sub in -2 into this polynomial, if I was to sub it in and say that's -2 to the 4th plus 4 times -2 to the 3rd plus 0 times -2 squared minus 2 times -2 plus 18. I just plug a -2 in for every x. What you would get is the remainder. So if I subbed all this in, I would end up just getting 6. That's exactly what this remainder theorem says. So if we wanted to use the remainder theorem to evaluate, what you're going to do when you turn in your scratch paper, whatever, on your test, on your quiz, to use the remainder theorem, you're going to do synthetic division. So I'm going to do synthetic division. If I want to find f of 2, I'm going to put a 2 on the outside. And then I'm going to put my coefficients on the inside, making sure I go in descending order. So there's 1x to the 4th, 6x to the 3rd, -12x squared, -30x, 35. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. The remainder is -9, so then I know that f of 2 equals -9. Take a second and try f of -7. Multiply. Oh, I did 2 again. We want to do a -7. Multiply, add, multiply, add, multiply, add, multiply, add. And so we get 0 as the remainder. Again, when I said earlier that you would love to get 0 as a remainder, right? Like on this problem here, when you got 0 as a remainder, that just means that it divided perfectly evenly. That's great. That just means that 2x minus 7 is a factor of 2x squared minus 3x minus 14. That means if I wanted to rewrite 2x squared minus 2x squared plus 3x minus 14, I could write it as x minus 2, 2x minus 7, right? These are two factors that make that polynomial. We just actually factored this using long division. You can say the same thing with synthetic division. So in this problem with synthetic division, since f of -7 turned out to be 0, that means that x plus 7 is a factor of f of x. That's the factor theorem, okay? So the remainder theorem says that whenever we do synthetic division, whatever this number is, the remainder, f of x is equal to that, right? So when I did f of -7 and got 0, that means that x plus 7 is a factor. My quotient would be written as, remember this, we started with a degree of 4, so this would be x to the third minus x squared minus 5x plus 5. Since it divided evenly, I can actually factor my polynomial like this. And I could continue to factor it down after that, right? This is helpful because initially, if I gave you this problem right here and told you to solve it or told you to factor it, if I told you find all the x-intercepts, find all the roots, whatever, it'd be really tough to do because we just don't have a factoring method that works for something with 5 terms. We have one that works with 4 terms with grouping, but we don't have one that works with 5 terms. And so what this gives us is a new method that we can use to factor down a polynomial. We could keep doing synthetic division. We could loop it and do it over and over and over again until we found all of our factors, right? This found us one factor. It found us one solution. -7 is a solution of f of x equals 0, right? Because f of -7 equals 0. It gave us one of the solutions. If f of x equals 0, that means y equals 0, right? And so that actually gives us the point -7 comma 0, which is an x-intercept. That's, again, very, very helpful information. We get a lot of information just from doing the remainder, doing synthetic division using the remainder theorem and the factor theorem. So this is true for any polynomial. If we sub in a number, get a remainder of 0, that tells us one of our factors, it tells us one of our solutions, and that solution is one of the x-intercepts. This is a lot of information to absorb, so if you need to pause and re-listen to that, absolutely do it. And at any point, if you need to go back to the factoring lesson and rewatch it, you could do that because this actually is now factorable. We could find the rest of the solutions. Remember, whatever the degree of a polynomial is, that's how many solutions we want to have. This gave us one of the solutions. That's one of the 4 solutions. One of the 4 solutions of f of x equals 0, right? All right, so both of these are points, right? I didn't state it exactly for this one up here. I did state it for here, right? The -7, we got out 0, that is a point. Here we subbed in 2, we got out -9. That means the point 2, -9 is another point on the graph. And again, just super helpful information. We just have one more piece of information about our polynomial that we can use to graph it. So here's what the graph looks like. 2, -9, we've got that point graphed. -7, 0, we've got that point graphed. Those are the 2 items that we plugged in with the remainder theorem, right? And so you could go and figure out the other x-intercepts using that same theorem or just using factoring if you wanted to. All right, let's see. Use the remainder theorem to determine if the given c is a 0 of the polynomial. To find out if it is a 0, that means that it should give us a remainder of 0. So let's check for a. Let's check for a and see if 4 is a 0 of that polynomial. So we'll say 4 on the outside. 2x to the third, -4x squared, -13x, minus 9. Bring down the 2, multiply, add, multiply, add, multiply, add. If that remainder is not 0, then 4 is not a 0, right? That's the same thing as saying it's not an x-intercept. Same thing as saying it's not a solution of f of x equals 0. Try the same thing on b. (1x to the third, 1x squared, -3x, minus 3. Bring down the 1. Multiply. When we add, we get 1 plus square root 3. When we multiply, we get square root 3 plus 3. When we add, we get square root 3. When we multiply, we get just a 3. And when we add, we get 0. Wow, I can't believe that worked out so nicely. We got a 0 remainder. That means that the square root of 3 is a 0 of f of x. That means it is an x-intercept. All right, I would take a second pause and see if you can figure these two out. Very similar to the last two examples. I'm going to pause for 5 seconds and then I'm going to erase and show you the solutions. The first one, it seems you get negative 19, which means that 2 is not a 0, but it does give you a point, 2 comma negative 19, that you can graph. The second one, square root of 7 does give you a 0 in the end, and so square root of 7 is a 0. We should say the square root of 7 is a 0, right? It means it is a solution. It is an x-intercept. When I say it's a solution to the problem f of x equals 0. If I set f of x equal to 0, it is a solution of that. It is an x-intercept. I get the point square root of 7 comma 0 as an x-intercept. All right, this is what I was talking about earlier. We can use the remainder theorem to find out if something is a factor as well. We talked about this just a second ago. Use the factor theorem to determine if the given polynomials are factors. So what we're going to do is we're going to use the remainder theorem. Remainder theorem and factor theorem go hand in hand. 1x to the fourth, negative 1x to the third, negative 11x squared, plus 11x, plus 12. X minus 3 means we need to put a positive 3. Remember, if we're trying to make it 0, 3 minus 3 would make that 0. You remember earlier I told you that it's easiest to use the remainder theorem if these things are just x and a number, right? So x minus 3 fits that category. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add, check. Since it turned out to be 0, that means that x minus 3 is a factor. Of f of x. I wish I had written this over a little to the left because I want to show you something here. So x minus 3 is a factor. And it also tells us that 3, 0 is a x-intercept. All right, I'm going to change colors and I'm going to show you something here. When we're doing synthetic division, if we do get 0 as the remainder, then what we can do is we can just carry on like down the line, okay? I don't have to rewrite my problem a whole bunch of times. If I get 0 as a remainder, now what I can do is just keep going and use only those 4 numbers that are left, right? So I can put a negative 2 out here and just use the 4 numbers that I have listed here. I don't have to go all the way back. Now you can only do this if you did get something that was a solution, right? If you did get 0 as a remainder. So now I'm going to bring down my 1, multiply, add, multiply, add, multiply, add. That is not 0. So negative 2 is not an x-intercept. We do have the point negative 2 comma 6, right? We can graph that point, but it does also tell us that x plus 2 is not a factor of f of x. So we didn't waste our time. We did get a point that we can graph. It's not just a total waste of time, but negative 2 is not one of the solutions, right? Negative 2 is not one of the zeros. X plus 2 is not one of the factors. All right, I love this. We have 4 terms here, and it sort of looks like something that we could do grouping with, and we look at it. We could try to do grouping. We could go back and watch that review again, try to do grouping, and it just doesn't work. What our problem says is to factor this, given that -5 is a 0. We know that -5 is one of the zeros. It tells us in the problem that it is. There's no other way to factor this. There's no grouping that will work. So what we're going to do is we're going to use our factor theorem and say if -5 is one of the solutions, we know that x plus 5 is one of the factors, right? My coefficients here are 3x to the third, 25x squared, 42x minus 40. I'm being careful every time that I have every one of those terms in descending order, and I don't need to place a 0 in there anywhere. If I was missing the x squared term, I would have to put a 0 there. All right, bring down the 3. Multiply. Add, multiply, add, multiply, add. Check. That is a 0. In fact, it is a 0. It did work. This is the same thing here as 3x squared plus 10x minus 8. And now that we're down to 3 terms, we can use star method to continue factoring. Remember, the top of star method is -24. Please go back and watch the review if you don't remember this. We're looking for numbers that go here and here that multiply to -24 and also add to 10. Multiply to -24 and add to 10. I'm thinking 8 and 3, 6 and 4. Seems like the magic combination. -6 and -4. Multiply to 24, -24. I'm sorry, multiply to... Oh, no, they don't multiply to -24. They multiply to +24. That doesn't work. All right, how about 8 and 3, 6 and 4, 2 and 12. So how about -2 and +12? Those multiply to -24, and they also add to a +10. That's great. I'm going to look at this side. I cannot simplify that fraction, so that gives me the factor 3x minus 2. I can simplify this one to 1 over 4, and that gives me 1x plus 4. I could have just carried on with synthetic division, right? So like we've got this factored all the way down now, but if I wanted to carry on with synthetic division, now that I know the answer, I'm going to erase this line right here. But now that I know the answer, if I had carried on with synthetic division and say I had chosen a -4, I'm going to show you how to pick those numbers right. It's really tough to know what numbers to put there, but we can narrow down the numbers that we're going to put there. But now that I'm at the answer, I know that -4 makes that 0. I'm going to put a -4 out there and just see what happens. Bring down the 3, multiply, add, multiply, add, check. So -4 would give you that factor. -5 would give you that factor. And then what's left here is 3x minus 2 gives you that factor. I prefer personally once you get down to 3 terms, so once we got to this step right here, I personally prefer once you get down to 3 terms to just go ahead and do star method. I find it a little bit faster than the guessing and checking and trying to find out which one works to give you 0, because if you tried any other number, it's not going to work. If you tried +5, +7, +3, whatever, it's just really hard to guess this number. Again, I'm going to give you a method that lets you narrow that down, but it's often easier once you get down to 3 terms to just go and do star method. And if star method doesn't work, then you're going to have to go and do quadratic formula. We're almost to the finish line here. It says to solve the equation. So here's where we just have to guess, you know? We just have to guess at numbers that go out on the left. I've already done the legwork here and found that -4 does work. So take a second and do that synthetic division. When you do the synthetic division, you end up with this polynomial. With that polynomial, I would prefer, once we get to 3 terms, to go ahead and do star method, where the top is a times c, the bottom is b, a and a go on the top, multiplying to -30 and adding to -13. We have -10 and -3. No, that doesn't work. -10 and +3 doesn't work. 6, 10, 5. 2 and 15. So if I had positive 15 and negative 2, those multiply to negative 30. Those also add to 13. I can simplify this fraction over here to 1 over 5. So that would be the factor x plus 5. Simplify this one. This one doesn't simplify, so that would just be 3x minus 2. It says to solve the equation. It doesn't say to factor it. So negative 4 is one of the solutions. We need 3 solutions total, right? Negative 4 is a solution because it gave us a 0 remainder. Negative 5 is a solution because it would make that 0. Positive 2 over 3 is a solution because it would make that 0. And now we have our 3 solutions. Remember, we needed 3 to begin with because our degree was 3. All right, last thing for this lesson, write a polynomial of degree 3 that has these 3 zeros. We're sort of reverse engineering a polynomial based on the zeros. If I have those zeros, then I know that I can have factors x minus 1/2. That would make that 0. Or, there's a lot of ways to write this. There's a lot of ways to write this polynomial. There's a bunch of polynomials of degree 3. Or I should say, there's a bunch that have a degree 3 that should go through those. Just based on the first coefficient, we can change it up a lot. So we could have x minus 1/2. We could also have 2x minus 1 if you could think that way, right? Because 2 times 1/2 minus 1 would give you 0. I think for everyone it would be easiest if we just did the x minus 1/2. It's going to make it more difficult. It's going to make it more difficult to do the actual distribution. It really helps if you can do this. If you could think about a fraction. So let's say I had 3 over 2. I'm trying to think of what that would go with. It would be 2x minus 3, right? Because 2 times 3/2 would be 3, minus 3 would be 0. If you can think that way, it's really going to help you in the long run. I'm going to use the bottom way. Either of these will work. Either is fine. All right, my next factor is going to be x minus square root 6. My next is going to be x plus square root 6. Because I know that that is a solution and that is a solution, right? I'm going to multiply these 2 items first because it's going to clean up those square roots. So I'm just going to bring down the 2x minus 1. Then I'm going to multiply x minus square root 6, x plus square root 6. I'm going to FOIL that, right? So that would be x squared minus x square root 6 plus x square root 6 minus 6. Square root 6 times square root 6 would just be 6. You can type that in your calculator and figure that out. Notice these middle terms are the exact opposite, so they'll actually go away. And here's what I was talking about. Multiplying those 2 terms first, I end up with just x squared minus 6. That's great. And now I need to distribute these 2 together or FOIL. And so that would be 2x to the 3rd minus x squared minus 12x plus 6. It says write a polynomial f of x. This is my f of x. That's one polynomial that you could have gotten. Again, you could have dozens. I mean, you could have, there's a bunch of options. There's unlimited options. I could have used this and gotten something totally different. All right, next lesson I'm going to show you how to sort of find those numbers that you're going to use with synthetic division, because that is the toughest part of this, right? Right now you're thinking, how would I ever come up with a -4, right? How would I ever come up with that number to go on the outside? That should be the question that you're thinking in your head, and that is something that we'll address.